Hello, everyone, and welcome to the Python Exchange. My name is Cameron Riddell, and will serve as your host for today. Today, we are joined by a very exciting guest panelist. We're joined by Vincent Warmerdam. And Vincent has spent his career cutting through hype with sharp engineering instincts and a deep respect for how data systems actually work. Vincent is a senior data professional whose roles have spanned from engineering, research, team leadership, and education. You may know him from his tech talks that he gives, where he champions a refreshing idea in modern data work: stay calm, understand the system, and always look at the data before firing up a mountain of tensors. His curiosity has always centered on how algorithmic systems behave and, more importantly, how they fail. That mindset has driven him to his current work at Marimo, where he's rethinking the Python notebook from the ground up and exploring what becomes possible when you challenge a decade of assumptions. So, in order to kick our event off, Vincent, I have one question for you, and that is so the audience can get to know you just a little bit better. What's one thing that you've worked on in Python recently that has been a lot of fun for you?
So I maintain over dozens of packages at this point. But you're going to see a demo of a library that I've been working on in a moment. In short, I made a tool such that you can draw a data set in your notebook. We're going to see a demo of that in a bit. Should be fun.
Awesome. Well, we love data visualization here, and I believe, Tom, you are at the right place as well. And so, Vincent, we'll turn things over to you so we can get started because I'm very excited to see all of these demos that you have.
Cool. So the best way to start a talk on Marimo, or at least that's kind of my experience, is to also start talking a little bit about Jupyter. So people that are looking at this is a relatively simple Jupyter notebook. Let's keep the zoom at this level. I've got a cell over here with the 1, A is equal to 1. I've got a cell over here, 2, B is equal to 2. So obviously, we know what A plus B has to be. Like there's only one possible solution, you would say, to this kind of. Oh, wait, what? How did that happen? Well, the thing with Jupyter is that you can do sort of things like this. I could do something like, oh, B is actually equal to 10 here. I'm going to run that. Then I'm going to sneakily escape and delete that cell. Then I'm going to put a comment in front of this cell, run it, and then, okay, oh, wait, you do see the number in front of it then. Okay, fine, I'll remove this. I will delete it, and then I'll add a new cell below. And, you kind of get this state. So you can do all sorts of fun, unexpected tomfoolery, but the big issue here is that what you're looking at on display is not necessarily the same as what's represented in memory. And Jupyter, because it really tries to mimic the REPL, also gives you complete freedom in what order you run the cells. And it's that sort of split between what we actually have in memory and what you're looking at on screen that's the cause of a lot of bugs. And a few years ago, my boss, the co-founder of Remo, was looking at this at Stanford, and he basically said, "Yeah, I want to design something new such that this stuff basically becomes impossible." So that's the whole premise of this new notebook. We're going to see a couple of features. We're going to see if you make a decision like that, there's also a couple of consequences. But that's going to be the main driving force behind what we're going to talk about. And one thing I should also admit, right? Like Jupyter, to be clear, is still an awesome project. If we think about like all the good that it did for the Python community and the algorithm community, just the ability to have like an interactive environment with charts, that's been super duper useful. But another difference that we're going to see in a moment is that Jupyter, even though it's mainly used in the Python community, it's actually a tool that's designed to allow for multiple language. So Julia, R, Python, Jupyter, that's kind of where the name came from. Marimo is very much a Python-only thing, and that's also going to have a couple of interesting consequences. But yeah, enough of Jupyter. Let's now actually start up Marimo. So what I can do is I can actually use UV. And I can just do UVX, type Marimo, and then edit, and then I'll just do notebook.py. And because UV can actually run this on the fly, you don't even have to start a Jupyter notebook or so a virtual environment or anything like that. So that's also like a super neat feature. And then, this is what a Marimo notebook looks like. Let's just set that to medium width. That is always a little bit nicer. I'm going to enter this first cell. And, from here, I'm basically going to try to repeat the same exercise as what I did before. A is equal to 1, B is equal to 2. I'm going to do A plus B here. People can see this, right? I hope. In terms of, yeah. Okay, so we can see that a plus b is equal to 3, and now I can start trying to do some tomfoolery. So let's set a equal to 10 now. And you're going to notice that the moment I do that, whenever I make a change here, this guy automatically updates, and there's no way around it. The way that it works, and you can also see that from the line down below over here, what Marimo is actually doing under the hood is it's saying, look, this cell over here, it needs two variables in order to run. It needs A, it needs B. Okay, so in order to run the cell, I first have to find the cell that defines A. Okay, found you. Okay, so that means that this cell has to run first. I also need B. Oh, that means that this cell has to run first. And here you can already kind of see a DAG. You can see that all these different cells eventually start depending on each other. And the order of which these cells are going to run is determined by when the variables are defined, basically. Okay, that solves the entire problem. So we're basically just going to say, look, where it's defined, it's going to propagate, and we're automatically going to update. And that's basically the mechanism that's going to hopefully fix everything. And there's a couple of interesting consequences when you want to have a notebook that way. Like, we actually don't allow for a few things. So this, for example, if you were to actually run this cell, then Marimo would have no way of knowing which variable A cell you actually mean. So if we had to run this, we'd have to make an assumption. So instead of allowing for this, we just throw an error. In Marimo, you are not allowed to redefine a variable, and you're also not allowed to do stuff like this. Because also in this case, if you do this more than once, we would again have to guess in what cell the order has to, we have to start making assumptions, and a lot of things just kind of go wrong. So we basically we're basically just super strict. Be very mindful when you're dealing with state, and if you're repeating yourself, if you're redeclaring a variable, we're just going to be very much in your face about it. And one funny thing also, there's a sidebar over here. There's a couple of interesting buttons. If you're interested in exploring how these cells are actually related to each other, you do have this DAG view where you can see how all the cells are linked. That is something that you can totally go ahead and inspect. We also have a mini map over here, so you can actually hover over a variable, and then you can go to the different cells where the variables are being used. So if you're interested in debugging with these graphs, there's stuff that we totally provide there, but this is the main thing that Marimo does and the main thing that Marimo enforces. And you get a very fancy thing like, okay, like cells automatically update. But another benefit of having this as the core premise is that you can also do little cheeky things like this. We can add a UI layer. So, let's just add a slider. Nothing too fancy, right? And then label, we can also attach that. So slider, exclamation point. We can have a variable here that represents the slider, and I can move it around. But that slider has a value property. And oh, well, how does that work then? Well, basically the same way. Like this cell needs this slider to be around. So whenever this slider updates, this cell will update. And whenever this cell updates, this value down below here updates. And wouldn't you know it, we have a full reactive notebook at our disposal by having this, basically. And when it's just a single slider, it's a fun little demo to explain the reactivity, but it's a little bit boring. Like it might be more fun to do something a little bit more elaborate. Um, so let's do that. But actually, before we go there, there's one extra thing I do want to maybe explain. So this automatic reactive updating, that's of course super cool, but you don't want that if you're dealing with heavy compute workloads. So if you're doing like a massive pandas thing or a massive polars thing, then you don't want to have cells automatically update or anything like that. So one thing that you can do is if you go to the bottom over here, you can see this on cell change button. Right now it's set to auto run. You can also specify that that has to be lazy instead. So if I were now to slide around, you're going to notice that there are these two cells that change color. That is an indication that these cells need to actually update to respond to the changes that I made earlier. And then you can do that manually if you so wish to do so. So you do have manual control over when cells actually do run. It's just the order in which the cells run. That is something that we maintain tight control over. But anyway, bit of a detail there. Let's now actually start doing something fun with data. And also, let's not do a slider. Let's actually use a library, one that I made. So from draw data, which is the library that I mentioned earlier, we can import this scatter widget. And oh, this guy is exciting. This lets you literally draw a data set. So I do have to wrap it with this any widget function over here. We'll just call that a widget. And also a fun fact. So what should happen right now if I were to run this cell? So I just wrote a little bit of code, right? And just imagine if this was Jupyter, what would you expect to happen here? Well, normally, if you were to run this in a Python script or something like that, you would get an error because draw data is not installed yet. However, whenever the program raises oh, there's a module that's missing error, we can pick it up and we can download it automatically on your behalf. So you don't have any of that exclamation points, pip install stuff you got to do inside of a Marimo notebook. We just automatically detect that the package is missing, and we can then do our best to make sure we get the right package for you. One thing we also do here is if you were to like import sklearn, then we will do the translation such as we install scikit-learn. So that translation between import name and like package name, that is something that we, what's this? Ooh, exciting error. Can I find for the pattern? Well, I'm pretty sure the library is called draw data, but it might be due because of a Python version.
Yeah, it looked like UV used 314.
Yeah, that is the thing that usually breaks it, isn't it? So Python 3.12. Let's just do that. Okay. Let's run everything, draw data. Yeah, that looks a bunch better. Okay, and let's run it now. Huh. Yeah, this is always fun during a live demo. I've never had this error before. What's happening here? So draw data. It seems like that's installed. Let's just restart this notebook just for good measure. Might be something else. Okay, draw data, install. Successfully installed draw data. No requires Python value found in workspace. Okay, we're gonna try one final thing, and otherwise, so I am also just in UV, so I can do UV pip install marimo. We're gonna stop using UVX now, and then marimo edit notebook in a normal virtual environment. There we go. Okay, this virtual environment has this widget installed anyway, so okay, we'll just accept this then. Zoom in though. Perfect. So this is the widget, and what you can see is I can actually draw myself a data set. So I'm going to draw a bunch of orange dots, a bunch of green ones, etc. But this is very much like the slider that we had before. So I'm going to zoom in a little bit again, and I'm going to do widget dot data as polars. And you're going to see the data frame that is being drawn here. So if I were to draw some more points here on top, you're going to see that this data frame down below updates. And again, that's the same behavior, except it's not a slider and an integer now. Now we're dealing with a proper widget and a polars data frame that comes out. So two things about both of these widgets. The first widget that you see over here, this one, this widget is something that's known as an any widget. That is a spec, you could say. There's a specification now, and if you follow that specification, the widget will work in VS Code, it will work in Google Colab, it will work in Jupyter, it will work in Marimo. It will basically work in all the notebook environments out there. It's this sort of common spec now that we've all come to accept. You can also make your own. There's a very lovely tutorial. Definitely check it out if you haven't already. But that widget, it will then update. We're going to get a data frame out. And whenever Marimo sees a data frame or something like a table, we give you this interactive widget that comes with a couple of interesting features. So one thing you could do, for example, is you can hit this magnifying glass, and then you can actually do text search in the entire data frame. So if I'm looking for label B, let's say, uh, B. Oh, the letter B is in there as well. C maybe. There you go. Label C, I can definitely do searches from here. That's, I think, a neat feature. We also have the column explorer. So if you're interested in maybe looking at distributions and some summary statistics, we can also pull that from the side as well. We have a chart builder. So if you're interested in making a chart, we have a bit of a GUI here. That's also very nice to the business users out there. But another thing I can also do from here, I mean, besides also per column, you can do all sorts of filtering. You can also download this as a CSV and whatnot. But one thing I can also do is I can store this into an actual variable. And the moment that I do that, there's a few things that are special that'll happen. For starters, in Marimo, we have this notion of a data source, and that can be a database with a table, or it can be a normal data frame. And the nice thing about it being a data source is that SQL can start talking to it, and LLMs can start talking to it. So to demonstrate SQL first, I can make a SQL cell appear here, and that's going to use DuckDB under the hood, and that's going to allow me to do something like select star from, and then I can point to that one data frame, and I'm going to have to install DuckDB and SQLglot. And then I'm probably going to have to install Arrow, or maybe that's already installed. We'll see. There we go. So we had to move some data into DuckDB. The thing had to get spun up. But the main thing I want to show here is that, hey, we also have support for SQL cells. That's kind of like a special citizen. And in this case, you can also just point it, you can point DuckDB in memory to whatever data frame you like. But you can also add different data sources. So if you have Postgres or MySQL or SQLite or MotherDuck or Iceberg or what have you, you basically get the same SQL experience right here. And another thing is also just kind of cute is I can also do something like add a limit here, like limit 5. And I've now specified an output variable. So what you can also do is you can write Polar's code and you throw that into SQL, but you can also write SQL code and the output of that is going to be a Polar's data frame. So what a lot of web people like to use this for is to like connect to a not necessarily production, but some sort of analytical database, but something that does receive live data and they need it for debugging. And by hooking SQL up like this, you can still get all of your Altair charts and stuff like that. One thing that can be helpful if you're writing Altair, especially for the first time, is that, you might need a little bit of help with the coding. So we have AI support as well. And one thing you can do is you can say add df, make me an Altair chart, X, Y axes, and color the dots. I'm using Gemini 2.5 Flash here. You can configure all sorts of models. But the main thing that's nice here is I'm referring to a variable that we have in memory. And that means that we can say things like, hey, how many rows, how many columns, and what are the types of all of these different columns? And that way I don't have to describe the data set to the LLM. The LLM can just immediately infer that. And that usually means that it's going to be able to do it just in one shot. I have to install Google Gen AI in order to run this. Let's retry. And hopefully the demo gods are with me on this one. This kind of looks good, so I can just add that to the notebook. Let's run it. And there we go. That looks pretty good too. Okay, so that looks like a pretty neat experience. What I can now do is just hide all the code and maybe zoom out a little. And what I can do is I can kind of turn this into a bit of an app. So if you remove all the code inputs, you can imagine that all the outputs of all of these different cells, that they can actually be pretty cool as far as creating an app goes. And that's actually a pattern we tend to see a lot too. So one thing you can do is you can run a notebook as normal in sort of quote unquote edit mode, but you can also export this as kind of a Streamlit app. If that's something that you're interested in, that'll also just totally go ahead and work. And, again, you can see the stuff just automatically updates. If I were to draw lots of red points here, you can see the Altair chart update down below as well. So hopefully people look at this and they kind of go like, all right, that's kind of neat. That's pretty cool. We have fancy features. But the next thing is like, Vincent, oh my God, we're going to put this into Git. Like, what's that going to be like? Do we have merge requests that are yay big because someone added a matplotlib chart? Like, how does that work? And also there, we kind of make a principled decision. But the easiest way to show you what this looks like is to just show you. So I just ran marimo edit notebook.py. What I can also just do is look at the file itself. This is what the file actually looks like. So we import some app. That app comes from marimo. And basically every cell is just a Python function that is decorated with this app.cell call over here. One thing you can see is that this cell, for example, it needs the MO variable to be around, which coincidentally we export in this cell. And you will also see that this cell over here exports a widget, and that widget is also used by some other cell. And you should never touch this notebook by hand. This is all being generated under the hood for you, but hopefully you can see a nice correspondence between, we have a cell, stuff goes into the cell, stuff goes out of it, and we have some cool tricks up our sleeve to make sure that we come up with good functions that represent cells in a consistent manner. Now, one thing I do want to show now, though, is this other cool thing because, um, it's a Python file, so maybe you can do very much Python things with it. So I'm going to start Marimo edit again, but now with a sandbox flag. And what that is going to let me do is it's going to run all of this in a separate sandbox. And, hopefully the demo works. It seems to, so that's good. And then, yeah, let's draw some data. And then when we do that, we are able to show that here. So that's also good. But if I were now to go back to the terminal and quit this and again have a look at the notebook, you're going to see that because I added a sandbox, UV is also able to add all of its dependencies here. And that also means that all of a sudden, this notebook doesn't need a requirements.txt file or anything like that. We're able to just have one file that also contains all the dependencies that we are interested in. And oh, another thing is also just kind of interesting and fun. This is a normal Python file. So if I were to call UV run, it is going to eventually hit this if dunder name equals main thing. And oh, if you have like a script but in the Marimo notebook, you can just run the Marimo notebook as if it's a normal Python script or with UV, and you get all the dependencies automatically installed as well. A few other things that might be good to point out. So you can see here that SQL cell that we have, it is really just a normal cell as you would normally. It's just that we have this mo.sql in the middle here. We do the same thing with Markdown, but basically, this is what Marimo is. We're really trying to enforce this reactive nature, and that led us to make a couple of decisions. But at the same time, we can also keep everything in a Python file, which means that the Git story is super nice. But also, every time that there's an upgrade for Python, it's just super easy for us to immediately add that to Marimo as well. I think I see a question as well. So someone is asking, how deeply can you trace the variables? So let's try. So I think if I recall correctly, we are doing some AST things, but I think we mainly look at a variable definition. So there's a question about closures. So I think if I were, yeah, okay, so exactly. So def outer, just to show that def inner, return just string of A, and then here we say return
Variable.
inner. Yeah, okay, but then where's the variable that we do assume that like variable A is defined outside somewhere, right? Something like this.
Yeah.
Okay, so we do see that like this thing over here is not, you see that line under it? So that means that we are detecting that if we change this cell over here, this has to rerun as well. So I think if I do something like F equals outer, something like that, and if I were now to take a cell here and I would call F, yeah, this would just totally work. And the reason why this totally works is because A is a global on the big scope on the outside. Oh, and we need A here. So before this cell can run, we got to figure out what A is. So that's how the chain then works.
I
So
see.
this cell becomes dependent on that cell.
What if you put an A between the outer and inner function definition so it's just non-local? Yeah, like A equals, yeah, 10.
Okay, but in this case, we detect, okay, you're referring to that guy over here. So now we can run this. It becomes 10, and I can change this. It's unaffected.
Cool.
Because this is no longer pointing to this variable over here.
Yep.
Yeah, we are properly using the Python AST here as well. So yeah, like one thing you can do, and this is shenanigans what I'm about to do, right? So like I'm not suggesting this is a good practice, but like one thing, if you wanted to sort of break the system here, like one thing you could potentially do is you could have like a list and you can append to that list. And I can append again. And we don't see an update. Only when I rerun the cell do we actually see the update. And the reason for this is that, oh, like, can we assume if the method is making an in-place change or if it's not? Oh, we can't. Like, we have no way of smelling that, basically. So, um, hmm. this is a bit of a conundrum, but the hope is kind of that people understand that if you're going to start doing things with state like this, then you're kind of expected to be mature about it and that you own the consequences. If you want to do stateful stuff, though, we do have the set state no, get state set state equals mo dot state. So you can put a list there, and I could call get state, and we then have a thing with nothing in it, and then I can have a set state here, lambda d, and then we could do something like d plus 1, something like this, right? And this has a proper getter and a setter, and this is like the neat way of doing it. And when you have two functions like this, then we can manage the state proper, right? So if you're going to do anything with state, and you typically do once you start building an app that's somewhat involved, then this is the way that you do it. Don't use a Python list. Wrap it like this, and you're good. That's the main thing as far as like state changes goes. Like this is how I would do that. The Python parser is limited in what it can statically determine, but that won't even work in Python code itself. So, I mean, yeah. So we're the thing is, the main thing I would say here is like if you're writing your pandas code the right way, you're fine. But you got to do stuff like df pipe and then have a transformation function like clean variables and pipe, maybe add sessions, or like you want to have these stateless operations like this. And this is a very nice way to get a clean data frame to come out. Like this is the way you want to write data frame code in general. But if you're going to be the person that says, no, I want to like do this all over the place, right? That's going to hurt. But if you do it in a stateless way, then you're going to be just fine. One thing that is good to mention maybe, so for I in range 10, if I were to just do pass on this one, right? A downside of writing a for loop is that, of course, you do define a variable. So if I were to add a new cell, what's happening? There we go. If I were to check the variable I, that exists now, right? Because of this for loop over here. And that means that you cannot reuse I, which can be a big pain in the butt. So one thing you could do is you could use underscore. Underscore is like a hidden variable. It's kind of like a throwaway thing. So that means that we're going to ignore it. But you can also do underscore I. And whenever there's an underscore in front of the variable, we assume that it's limited just to the one cell where it's defined. And we're going to assume it's thrown away afterwards. So that means that you can totally have two of these for loops, even though they reuse the same variable on paper, right? Like this is totally fine. So if there are these moments when you want to reuse a variable because of a for loop, this is the way you would do it. Probably the most common thing that won't work would be df query with at references to variables. I mean, yeah, that's possible. I should mention that, and this is like a highly personal preference, I've completely switched to polars at this point. Like sometimes there are these moments when I still want to use pandas because some other library depends on it. But thanks to narwhals, that's also becoming like increasingly rare. Also, narwhals is what we use under the hood as well to support all these different data frame formats, which has been a godsend, honestly. It really makes our days a whole lot simpler. Right. So with that thing done, I'm just gonna do this one other thing that I think is a cute demo as well. So I'm gonna have def hello here, and then I'm gonna do something like print hello. That's something I think I can do. You're gonna notice the moment that I define this cell, it is deemed reusable. And that makes sense because this function doesn't have any dependencies. And even if it did have dependencies, one thing I could do is I could add a setup cell. So I could do something like import polars as PL. And then, I don't know, I could do pl.read CSV and then like not even use it. But technically, this function now actually needs polars around. But it's still reusable because I've declared this one special cell. It's called a setup cell. And any dependencies that are listed here or in any other reusable cell, that turns this function into something that we are also able to export. And this is something that's a bit counterintuitive to a lot of people because people don't think about this when they're thinking about notebooks. But again, if we have a look at that notebook.py file, Normally, a cell inside a marimo is just this anonymous function, really, that's just decorated and we put stuff in it. But this is not something you can import from another Python file. But by declaring a cell that's reusable, by just having one function in there that we expose, we are able to do something clever that we add a different decorator on top. And this way you can actually define a function inside of a Remo notebook that other notebooks could import, other scripts could import, but also other libraries. So famously, there's a demo that I've made. You can define a fast API app by having a create app function call. And then UVcorn, you can just point to a notebook file and it'll just run your fast API app for you. So that's something that is a little bit unexpected, but something that we do totally support. Another thing that we also like to play around with sometimes is let's add another Python cell. And I could do something def test hello and assert true, a bit of a silly example as well. And let's actually go to packages and install PyTest because that's right, Marimo also supports PyTest. What you can do is just have a cell where all the functions start with test underscore, and we will just run PyTest for you. So if you want to include PyTests to your notebook, you totally can. And another fun fact, you can also do PyTest notebook.py. Oh, uv pip install PyTest. So if you want to have a notebook and you want to have tests run in CI, that is also something that you can totally do. And then I think I'm going to move towards maybe the final demo that I think will be cool to show. Another thing that we can also do is do stuff like this, where I have the Marimo helper around, and there is this app meta information that I'm able to access. So I'm able to check, like, hey, are we running as a script from the command line? And if that's the case, then we're going to print something special. And now if I were to go back here and do uv run notebook.py, we should see a print statement. Hello, there we go. So, right, and then uv pip install arrow, I guess. That's something we might need to run this whole thing without errors. I'll ignore that for now. The main thing that I care about is the fact that we're able to print here because of this. You can actually add some extra context. So you can add logic here such that, oh, but if we're running this from PyTest, oh, then we want to add these extra variables, maybe have a fixture. And oh, if we're running this from the command line, oh, then I want to have typo around as well and sort of go forth and do things that way. But again, these are just old demos. These are things that you can do with Marimo. But maybe the coolest thing to think about is the fact that, oh, we are able to just rethink the way that you interact with a notebook nowadays. And like final demo, DiceKit, I think, is a really nice example. So this is a library that it's really just a notebook, and then I have a build script that turns this into a proper Python package. But just to like emphasize a few things here, so I'll turn light mode. This is GitHub Pages that I'm about to open, and you're going to notice that we have a full Marimo notebook running on GitHub Pages. That is because a Pi died. So just like Jupyter Lite, we have this one version of Marimo that can run fully in the browser. And people can interact. So like docs pages are just made with Marimo these days, and instead of having a static doc that you look at, you're actually actively invited to play around. But like one thing you can also do in Marimo is you can set the representation of an object not to be a boring string, but to be something exciting, like, I don't know, a chart. And the whole thing with DiceKit is this is just a package that lets you play around with dice, but in particular, it lets you play around with probability distributions that you can find with dice. So you could, for example, add a 6-sided dice to an 8-sided dice and then get a pretty distribution out. Not only that, you can also play around with the slider. So you can do things like, oh, hang on, maybe I will have a dice with like 5 sides or like 80 sides. And then if I want to have the max value of like rolling it once or the max value of rolling it twice or the max value of rolling it 3 times, I can have different distributions for that. That's actually kind of cool too. And, you can also do things like, oh, there's an event for like, I'm rolling a d20, and what's the maximum out of 2? What's the probability that it's higher than a normal d20? And there's like convenience functions that I can make and things like order statistics and all sorts of cool things. But huh, just the fact that I can come up with objects that have a proper representation. Oh, and I can add sliders to my heart's content. This is a really playful environment. I would have never thought I would do stuff like this in Python. But again, this whole demo is implemented in just one notebook. There's this one dice class over here, and the way that you define that custom display, by the way, you just do this basically. You just underscore repr HTML as you would normally for Jupyter things as well. And yeah, ever since I started using Remo, I've just noticed that it allows me to rethink what I can do with Python. Because we have all these things that the browser offers, it's not just the widgets, it's also the reactive nature of things that I'm able to sort of have a bit more fun. And if people are interested in sort of keeping track of the stuff that I do, I think this demo is still up. This is I have a library full of widgets, and the library is called Wiggly Stuff. Um, yeah, and I think it's broken because I'm currently working on it. But like this library has a 2D slider, so you can have an X and a Y coordinate, and you can slide the puck around and have two values updated at the same time. I also have a matrix widget where you can define a matrix and then slide values around in the matrix and see things update. Um, I've got a copy to clipboard widget, a keystroke widget for keyboard shortcuts. There's a demo of me. Let me grab it. Turns out that the browser actually has a gamepad API. So I've actually managed to find a way to actually control my Python code using a gamepad. And that's amazing if you want to do data annotations. So there's all these things that you can do now that we kind of have first-class support for Python in a notebook like this, but also the fact that you're able to build your own widgets. Like there's a lot of cool things that you can do, and we're really just starting scratching the surface of all of this here. So I think this is a nice place to maybe stop and then have people ask questions. But the main thought I want to leave you with is like, oh, right. We can do different things in notebooks now. And like, it's not so much the features of Marimo, it's more the fact that it's different now and you should let your mind free and be more creative. That's the main point that I want to make. Because I honestly feel like I can dream of different things now because of the stack. End of speech.
Awesome. Well, thank you so much, Vincent. This has been an amazing tour of Marimo. So let's go ahead and open up the Q&A. If you're in the audience and you have a question, please go ahead, enter that question either in the chat or in the Q&A widget. But also to help us with our questions, we have our team of host panelists who I'd love to introduce. Let's start off with Justin and then James and then Tom. But Justin, it's great to have you join us today. Can you share with us a little bit about a Python project or a little bit of Python work that you do so that our audience can get to know you a little bit better?
Sure. So my name's Justin Goodrich. I'm at NSLS2 at the Brookhaven National Lab, and I work at the Coherent Hard X-ray Scattering Beamline. An example of something I was working on recently is, we have a lot of legacy, kind of old code for our XPCS analysis, calculating these autocorrelations and two-time correlations from X-ray, coherent X-ray data. And one of the things I've been working on recently is using GPUs to speed it up. In particular, trying to figure out, there's a lot of challenges with that, figuring out how to batch these large data sets to the GPU. But it's been exciting, for one of our projects, for one particular type of analysis, we got almost 1,000 times speed up. So working on getting that into production.
That is awesome to hear. And you and everyone else is loving the GPU. So I'm very glad to hear that you were able to get that speed up that everyone seems to talk about, but it's so hard to actually obtain.
Yeah, it is.
Awesome. Well, it's great to have you here, Justin. Let's next go to James and then Tom. James, can you share with us a little bit of a Python project that you found fun that you've been recently working on?
I'll answer the opposite question. I have recently been doing quite a bit of work on a discrete event simulator, not written in Python, but written in C++ for quote unquote performance reasons, that is slowly ruining my life. And yet, if you talk about discrete event simulators, Python is still actually a very, very good choice to write these tools. For performance purposes, if you're interested in discrete event simulation and how to write actually fast discrete event simulators that will not ruin your life in Python with C++ for some of the number crunching parts, I'd love to talk to you.
Awesome. Well, James, it is always great to have you join us with your Python intellect and your C++ knowledge. You always have very engaging questions. Tom, last but certainly not least, can you tell us a little bit about a Python project that you're working on that is either fun or maybe like James's project, some begrudging work that you seem to make through?
So, my fun project is I have a pile of scripts that will build from CPython, the main branch up through the entire SciPy stack of the development branch of everything. I use this as a canary to detect when upstream changes are going to break something I care about. But if this seems like a fun thing to do, I'm always looking for anybody else who would like to participate in this activity.
Fantastic. I'm actually curious, do you automate that? Just run that like on a cron job either locally or through like some GitHub action?
Uh, no, it currently requires a lot of system dependencies, so getting it set up on CI is a little gnarly. I did take a chance to try like a pass to try and put in a container, but it requires like 7 gigs of source checkouts, which doesn't play nice with containers.
Yeah.
Um, and it fails often enough that it's just uh you run it and see what breaks.
Yeah. Well, very fun.
And then
Tom, it's
once I have that environment, I try to use it as my day-to-day work.
oh yes, that makes a lot of sense. And then at least yeah, if it breaks in your day-to-day, then you know something's coming down the pipeline that you need to prepare for. Awesome. Well, Tom, it's great to have you here as well. Now, let's kick off the Q&A. I see that there's already one in the chat, and James, I saw you had your hand up a moment ago. Let's take the one
can I answer
in the
one question
chat.
from James already? Because there's a mention of like, oh, gamepads and controllers and Jupyter
Yes,
widgets,
please
and
go ahead, Vincent.
no one has ever done anything useful with it though. So can I give this one demo? I've got a list of strings, and these are tweets. And some of them, like I need to check, like, is this about a late delivery? Yes or no? I've done some sort of a LLM thing. It got me some responses, RAG. Oh, but it makes mistakes. To me, it's a whole lot nicer to just have a gamepad controller and like do all the wiring with Python. But I can go yes, yes, no, no, yes, yes, no, no. Oh wait, I have to go back now. Okay, maybe skip this one. And oh, I can also add annotations, which is really nice. This is also happening via the web speech to text API. And when I let go, I can add not just annotations, but also context. So then if there's a label error or something like that, I can add context for maybe the next person. I am a kind of person who's had plenty of RSI issues, as you can see from the rack behind me. I type on these kinds of keyboards nowadays. So I like having an ergonomic device when I'm annotating data, sometimes for like an hour on end. And for this use case, I will say a gamepad is amazing, but also being able to do all the routing with Python and still having like a bit of a widget, that's just super duper neat. So for me, the gamepad, the main use case really is data annotation. And one of my goals at Marimo is to make sure that that's actually doable inside of a notebook. So, but that is a legit use case, I would say.
Very fair. All right. So let's jump into the first question that came through the chat. And Vincent, I saw you already responded to it, but the question is about parameterizing notebooks. It's great that you can run notebooks just from your terminal or your shell, but can I pass arguments to it? Something like
Yes.
configuration parameters.
Yeah, totally. So Marimo edit notebook .py, right? We had that guy. Yeah, let's sandbox it, open it up. I am gonna remove a couple of things now just to keep this notebook a bit clean. So there's like a bunch of ways to parameterize a notebook. As mentioned before, I think. Oh, I stopped importing Marimo. Yeah. Okay, delete. This all looks pretty clean now. Import Marimo as mo. That looks pretty good. Mo cle args. So this is something that we've got natively built in, and let's just print that for good measure. There we go. I'm now going to exit this notebook, and I'm now just going to do the uv run notebook.py and do me a hello world. And apparently there's still a lingering thing around. Oh, right. Yeah. So that's why. Fine. But if I now were to run this, then you can see I've got this dictionary. Good. Bye. So if you're running this from the terminal, you can pass whatever extra arguments that you like. And we have this dictionary that can sort of just fold all of that in. I use this a lot with Pydantic. So there's like one Pydantic object that's like pretty formal and is able to validate all sorts of things. And then basically this dictionary gets thrown in there, and that gives me the best of both worlds. That's like a pattern that I do tend to use. You can also just host a click or a typer app in here. Again, it is just the Python file. So that's also totally a legit approach. But like the dot cli underscore args method. That is by far the easiest way to get started.
That's awesome. And I really see how that appreciates that Marimo is kind of taking this concept of a notebook script in a very literal sense. It is very much a hybrid between the two. And I think being
Well,
able to pass arguments to it is incredibly useful.
but mainly it is still just a Python file. So literally anything you can do in Python, you can still do inside of Marimo. It's just that we also want to be a notebook, coincidentally. So yeah, I write a lot of command line apps in notebooks nowadays, and it's just the bee's knees. Also because the thing I really love about it is you've got one file, and because of UV, we have all the dependencies attached. And because we support PyTest, the file also has all my tests. And if you use typer, which is my favorite, any function that you decorate with like a command line utility can still be used as a normal Python function as well. So you just get all this stuff for free by just using a couple of sane Python patterns. And command line, we're very friendly to that for sure.
Awesome. Now, I did have a follow-up question on that idea.
Mhm.
I noticed that when you open up the scripts or the notebooks inside of just a bat or whatever viewer,
Oh yeah.
um, everything's wrapped inside of a decorated function. If I
hmm
were to define my own function in the notebook, is there any way I can import that into another script? But
Oh yeah.
yeah,
That's the let me that's yeah, so let's just do that's the hello thing I showed earlier. So def hello, right? And then return one. This is a reusable function. So what we don't want is that you define a variable here somewhere, and we do want that to be specific. Any dependencies of a function that's reusable has to be defined in the setup cell or another reusable function. That is a
mhm.
rule. But I'm going to save this file now, and if I were now to do bat notebook, bat notebook.py, then you are going to see that reusable function is just a normal
Ah,
Python function. So
very
that is
cool.
exposable. So um, Python scripts can use it. Other Marimo notebooks can go ahead and use it. But also, again, fast API apps, if you use the create app way of defining a new app, you have one function that returns a fast API app or something like that. Then UVcorn can just go ahead and run with it. So I have a few fast API apps in production where it's just UVcorn, point to the notebook, and it just runs the whole thing.
Awesome. All right, one follow-up question in the chat, and then I do want to hear from our panelists. So Tom, Justin, and James, get your question caps on. But before we get to you all, it's a follow-up question from the CLI asking if there's a way to save
Ah,
output in the notebooks or adjacent to them. For example, suppose you have a cell that does some lengthy computation and you want to save the results. Is that possible?
it is, but also like this is a really good question too, because one of the reasons why this is so nice for Git is because we don't store the output. But a very good follow-up question is like, but what if we want to? So let's edit this notebook. There's a few things you can do. So you can download this notebook as a rendered HTML file. So that's a thing you can do. You can also download this as Markdown or Python. And I think there's even a way for us to store this as an IPyNB file if you so wanted to. Another thing you could also do though is Marimo export dash dash help. You can also choose to export the Marimo notebook as a WASM HTML file. And that way, assuming that you're using Python packages that are all WASM and PyDot compatible, you can actually get a folder with lots of dependencies in it. But then you're going to ship the entire notebook, and that's then something you can host statically as well. Um, Personally, I've actually noticed that I don't mind not having any HTML outputs in my notebook now, just because of the Git story that just gets so much better. Um, but this can still be a very nice option for things like GitHub pages. That definitely is very nice.
Yeah, that's awesome. And I appreciate that because how often have I opened up Jupyter notebooks and there's output in there, but it's stale output. It's not even accurately representing what code was actually executed the last time the thing was run.
Yeah, so the funny joke that we kind of make is people come for the Git story and they stay for everything else basically. But we've noticed that a lot of the more engineering archetype people, they really appreciate the fact that it's just a Python file and that just the whole Git thing is just so much easier. That seems to be a big attraction to a lot of folks. So, but yeah, you have to be a little bit manual if you want to store your matplotlib charts. That is a thing to be mindful of. Another like there's a technicality here. So Marimo also ships with a caching mechanism. So it's a little bit early. There's more features we want to add, but like one thing you can do is, oh, if all of these cells didn't change, the output of like the final cell, oh, that's something that we've already got in our cache. And then if you were to restart the notebook, it's actually not going to run any code. It's just going to fetch everything from the cache right away. If you want to share that, that means you have to share the whole cache. So like that, there's a little extra sort of dimension to it, but that's also like a way of maybe shipping the notebook. Like one dream we have is that at some point it might be cool if like you have a full Marimo notebook and then you're able to export that into some form of markdown that you can put on your blog. And even though no actual Python code is running, like all the UIs, they do cause all the HTML pictures, the matplotlib charts to change and like all that good stuff. That's something that we might want to build at some point as well. Dreaming, again, this is not a feature just yet.
For now, we'll just ship static HTML to our blog pages.
For now, we think the piloted WASM version is pretty exciting too. Yes.
Yeah. Yeah. That's amazing because I know Jupyter has been playing around with a lot of that stuff, but I haven't seen it been executed very successfully just yet.
So there's a chance that and I'm talking to them, this hasn't been confirmed yet, but like I have a version running for the Altair docs, such that if you want to, oh, there's a nice example of Altair, you can copy that and paste it into your own notebook, but maybe in the near future, you can also just open up a tab, like there's a UI thing on the Altair docs itself, and it just lets you code the Altair chart live inside of a Marimo notebook that is hosted on their end statically. That's something we might see in the future.
Very, very nice. But let's also hear from our host panelists. Tom, Justin, James, any questions or any thoughts? Are you still skeptical about Marimo? Or are there any features that you think are missing? Tom, I see you came off mute.
I just said I asked my mean question already, which is the one about closures.
Perfect. And James, you have your hand up?
I have a question about the community and collaboration angle. As I
Sure.
understand it, Marimo can convert IPyMBs into its format, but there's a
Yep.
conversion process intermediating between your original notebooks and the Marimo format. And I wonder, to what degree is Marimo interested in collaborating with the enormous body of work that has already been done for the Jupyter community? They have plugins and widgets and whatnot. Or alternatively, to what degree has the Jupyter community failed to create an effective environment for collaboration, forcing Marimo to kind of forge its own path?
I mean, I don't know the full history lesson there, but there's a couple of things of context, right? So the any widget spec that I mentioned earlier, like if you want to make your own widgets, basically this is our way of thinking about how if you want to build something custom, this is the way to do it. Because if you build it in any widget, it will also work in Jupyter. It will also work elsewhere. Trevor Mance is the one who built this, and he's a colleague of mine. So he actually also gets paid a little bit to work to keep like supporting any widget proper. So like we're super cool to do that because we like widgets, and widgets have first class support in Marimo, but we certainly don't mind that people love using them inside of Jupyter as well. So like that is like one thing that I think we should mention. And I mean, from my perspective, it's not just Marimo that's out there like trying to rethink a notebook. You've also got DeepNote that got open sourced recently, I think. I mean, there's a bunch of movement. And the way I just kind of experience it is that, Jupyter is still a cool project. It just got really big. And when projects get really big and people depend on them, it's a little bit more slow moving and it's hard to take out the engine and replace it with something completely different. That's totally normal. That's the way that open source works. So like, I have no hard feelings at all in that sense. I just find Marimo to be like a refreshing alternative, and I would love it if more people would do that. Another really cool approach, we have some ideas in common with them, but the Jeremy Howard, people might know him. He did Fast AI, those courses. He's now doing Answer AI, and he's also working on a new notebook that's all about, oh, how can we get a notebook with an LLM working? And he's like a very specific viewpoint on that. It's called Solve It. From my perspective, it's super cool that more people are playing around with different kinds of notebooks. And the way I would just experience it is that Marimo just took a lot of inspiration from Jupyter, as in there's stuff we would like to change. And then it got a lot of inspiration from the observable notebook, from JavaScript, and from Pluto, from Julia. So like it's, from my perspective, this is how open source is supposed to work. People try out new ideas. Some of them become successful. There's bundling, there's unbundling, there's chaos. And Marimo is just a attempt to make a better notebook, and it's taking a certain direction. We're also not going to support other languages, for example. Jupyter does. So I would just, from my perspective, it's mainly just, oh, it's a different thing. And people do seem to like it, which I'm happy with. But Jupyter should just do whatever Jupyter feels like doing. I don't feel like I'm in a position to tell them what to do.
Do you think the advantages of having multiple languages never really materialized for the Jupyter community? People just stuck to whatever language they were most comfortable in?
Um, Maybe, but I still think it's cool they tried, if that makes sense. Like, I remember when the thing just came out, right? Like, we had the IPython notebook for a while that only did Python, and when people made the argument of, oh, maybe we should do other languages in here as well, I mean, it felt like a compelling argument to me. Um, but as always, the whole point of open source is that people should just try things, and only after a few years do you find out what actually sticks.
Makes sense. And anecdotally, I have the same experience where people will really just use Jupyter notebooks for Python, but I am coming from a Python perspective, so that's probably a very biased experience that I have. That said, Justin, I see that your hand is up. Did you also have a question or
Yeah, I
a
have
tangent?
I have one or two, maybe two related questions that I'll kind of pose. Or so, first question is, if you have a large organization like somewhere like a light source, right, that has infrastructure built around using Jupyter, what Jupyter Hub, Jupyter Lab, etc. What are the biggest challenges, would you say, for getting that institution if they wanted to move to Marino to actually do so?
I mean, a bunch of things are actually pretty simple because it's just a Python file, and I'm going to make the astute assumption that if they're able to do stuff with Jupyter notebooks, they're probably also able to do stuff with Python scripts. And if you're able to do something with Python scripts, you're able to do something with Marimo. Um, that's mainly from oh, I'm running something locally, and then I just push that as a script somewhere, and then use it in Airflow or something. So, like, there's a lot of paths like that I do think are like pretty easy. One thing that we do have, I'm just going to mention that real quick. So, um, maybe I can actually, Marimo support Colab GitHub issue. Yeah. So this was the number one upvoted in 2024. The number one upvoted Python request for Colab was to add Marimo support. So we just went ahead and built our own. So if you want to use notebooks like this, maybe hosted somewhere, we do have a cloud hosted version for that if that's like something people are interested in. We have a bunch of free compute to spend on this, by the way. So like that's a thing I just want to plug. One thing you can imagine is that we are gonna maybe do Jupyter Lab stuff at some point as well, because we do get those questions being asked to us. It's just that we're a small team and we're pretty happy that we're a small team because we get a lot of stuff done. But it also means that we have to say not now to a couple of features that we would like to do. So I definitely can imagine that we are going to do some Jupyter Hub stuff. Wasn't there like a Jupyter Hub Marimo integration already? Yeah, so I do remember this community member. I don't know if this is, I don't know how well this is supported, but I do remember someone having a Jupyter Marimo proxy. I've never used this myself though, so I want to be a bit careful with promises. But there are people trying out things. We probably will have something of might be like if you're a team, how do you want to use Marimo? There's like a story there that we do want to have an answer for. Right now, we kind of don't, besides the MoLab experience. But there are people trying. That's the one thing I can report.
Cool. And I guess my related question is, we use Jupyter notebooks quite a lot at my beeline for kind of doing analysis and making, nice files for users to look at the results. But we have dozens of different notebook templates, I guess you could say, and we run them with Papermill right now. If I wanted to transfer all over, is that just me spending a couple hours just copying from notebooks into Burrito, or how would that look? What would that look like if I wanted to do that kind of efficiency?
We have
Efficiently.
a Marimo convert
Oh, okay.
as well. One thing about that. So imagine that you have a notebook that does something like A is equal to 1, and then the cell below does A is equal to 2. Then we are going to have to do our absolute best to make that Marimo compatible. And then we are going to do a variable renaming thing in order to do our best to make sure that things are still in sync. And we are also going to have to assume that the order in which the cells were written in Jupyter, that that's also the order they're meant to be executed in. This is an
Sure.
assumption that's not always true, right? um, But with those assumptions, we can attempt a conversion. I don't know if we can do the paper mill thing though. That's the one thing I want to be a little bit careful with.
Sure.
Um, but this is a legit attempt though. Most of the time this will work.
Awesome.
Like that, I'm sure I'm able to find like an edge case where something bad happens. But like one thing I can imagine, for example, is if you have a notebook where I think right now it was on the issue tracker, so it might have been fixed already. But right now, if you have like exclamation point pip install something, then that's actually kind of a weird bash magic thing that Jupyter does, and we don't support that. So right now we're going to throw an error. We are trying to tackle all those little edge cases. Another thing is that we, in the end, do not support Jupyter widgets. They have their own little spec. We support the AnyWidget spec, which is more general, but stuff that is like really specific to Jupyter, like IPython widgets, for example, not all, we can't guarantee that all of those will work.
Got it. Thank you.
But bread and butter, like pandas stuff with some matplotlib, that should just go ahead and work.
Awesome.
Fantastic. Well, that brings us to the end of our time for today, and it has been a lot of fun. I want to thank our host panelists, Justin, James, and Tom, for your insightful discussion, and of course for Vincent for the very engaging chats and demonstrations. Of course, a huge thank you goes out to our audience because I want to see you all next month, or should I say next year, where we're going to be joined by Dr. Jordan Stark. So keep an eye out on our website, that's meetup.doepy.org, for updates on the specific date and time. Have a happy new year, and we'll see you all again next month. Thanks, everyone. See you next time.